Okay, one more time. X-intercept and y-intercept. X-intercept 1/4, y-intercept -3. And students have a tendency to not like this problem until I remind them that this is the same as passing through the points 0 or not 0, I was going to do the first one, 1/4 0 and 0 -3. That remember, when you know an intercept, the other coordinate is 0. So when they tell me what the x-intercept is, the x-intercept is 1/4. That tells me the x-coordinate is 1/4. The y-coordinate is 0. Y-intercept 0, -3 tells me that the x-coordinate has to be 0. Y-coordinate has to be -3. And now we're going to do a really similar thing. We'll start with finding the slope. Find the slope. And so y1, y2, x2, y2. If you need to do that. If you don't need to do that, don't. So y2 minus y1 over x2 minus x1. So we got -3 minus 0, 0 minus 1/4. Which gives me -3 over -1/4. 3 over 1/4. And no, you cannot give me that as a slope. You got to simplify that. Remember, fractions are nothing but division. And so all this means is 3 divided by 1/4. That's all that means. Fractions just mean numerator divided by denominator. So 3 divided by 1/4, which is 3 times 4 over 1, or 12. Now, you could use slope, you could use y equals mx plus b here, because we know the b, and that'd be fine if they didn't tell us to use point slope. So point slope, because that's one of the answers they wanted. But then this gives me an opportunity to say again, you can use whichever point you want. Use the easiest. That guy's not the easiest. This is the easiest. So y minus -3 equals 12 times x minus 0. Or that'd be y plus 3 equals 12x. Then slope intercept. Well, that's just going to be moving that 3 over. Then general form. Zero equals 12x minus y minus 3. I don't care what side your 0 is on. Well, I don't care about this form at all. I certainly don't care what side your 0 is on. The computer might want the 0 on the other side. If the computer wants the 0 on the other side, put the 0 on the other side for the computer. So there's that one. We're going to do this 2 more times. I know I'm hitting this hard, but like I said, this is a topic that if you go on to calculus, they just expect you to know. And we get to use what we learned about parallel and perpendicular lines a little while earlier. Find the equation of the line passing through the point, -4, 5, parallel to the line whose equation is y equal 2x plus 3. So I still find the slope. And we're going to use that we are parallel to y equal 2x plus 3. We call parallel lines have equal slopes. So m equals 2. That I can just, since this is in slope-intercept form, I can just pull off that 2, and my slope is 2. And 3, use point slope, or not 3, this is step 2. Use point slope. So what do we got? Y minus 5 equals 2 times x minus negative 4, and that's y minus 5 equals 2 times x plus 4. So there's my slope-intercept, or point slope, excuse me. And then slope-intercept, that's going to give me y minus 5 equals 2x plus 8. Add the 5 to each side, y equals 2x plus 13. And then you can do general form too. I don't care about general form, so I'm not going to do that. But I do like to show checking things, because if you have a few moments, you can check these things by looking at some pictures. So here I'm going to graph two things. I'm going to graph my answer line and my parallel line, but I'm not going to necessarily do it at the same time. So I'm going to do the 2x plus y equals 2x plus 13 first. And so y equals, and clear that out, 2x plus 13, zoom 6. There's my line. It's supposed to go through negative 4, 5, so trace, negative 4, then hit enter. And you can see it at the bottom. I'm not going to zoom in, but it is down there, y equal 5. So that's right. Now, we do actually know that they have to be parallel because they have the same slope, but if I put in there also the other line they told me about, 2x plus 3, and graph that, there's my answer line, there's the line they told me about, and indeed they are parallel. So we know this guy is right. Last one of these things. An equation for line L. L is perpendicular to y equals 2x. So we're finding the equation of this guy right here. Find this line. Find this line. Okay, same basic steps. Got to find the slope. Here we're going to use that we are perpendicular to y equals 2x. So we go back to the fact that we had a while back. Recall, perpendicular lines have negative reciprocals for slopes. So one slope, y equal 2x, m is 2, 2 over 1. So line L, the guy we're looking for, the red line, the answer, m will equal negative 1/2, negative reciprocal. And then once we do that, same steps as before. They told me a point. There's my x1, y1. So, step 2, y minus y1 equals m times x minus x1. And so that's going to be y minus negative 4 equals negative 1/2 times x minus negative 2. And so there's the slope-intercept. Excuse me, point slope. I always say slope-intercept, but that's point slope. And then going to slope-intercept. Got y plus 4 equals negative 1/2 x minus 1. So I got the 3, that's going to be plus 2 in there. Plus 2 times negative 1/2 is negative 1. Subtract the 4 from both sides, y equals negative 1/2 x. Minus 5. And again, we will check that one too, because since these are lectures, I can just talk as long as I want. So we will check that. So I'm going to put my answer in there, clear out the old lines. And so we've got y equal negative 1/2. And I'm just putting the fraction parentheses just to emphasize here is my slope. Press the wrong button. X minus 5, standard window to begin with, zoom 6. And that was supposed to go through the point negative 2, 4. So let's trace it. Negative 2, enter. Negative 2, 4, so I feel good about life. And we do know that we have that perpendicular nature just because of the negative reciprocal for the slopes. So I feel good, I would go away happy. But I want to show you what I was talking about the calculator before. I'm going to put in the other line that they told me. That they told me that it should be perpendicular to x. Now if I hit zoom 6, the standard window, there's my answer line, and we felt good that that was right. And there's the line that they told me that it was supposed to be perpendicular. And if you notice here, especially this angle right here, that that's not a right angle. It's close to being a right angle, but it's not a perfect square corner. That is because your calculator is not measuring the x and y axis in the same way. Yes, it's counting from negative 10 to 10, but the tick marks are further apart on the y-axis, on the x-axis than the y-axis. If you don't want things distorted, what you have to do is press zoom and then option 5, zoom square. And when I press zoom square, there's my answer line, there's my perpendicular line, and those guys look perpendicular. And then you can still do the trace part, trace, and it was supposed to go through the point negative 2, 4, so trace, negative 2, enter, and indeed it's going through negative 2, 4, and it looks almost identical to the picture that we have up there. So we are sure that that is all correct. Got a few moments on a test? Check these things that you can check. Okay, last topic in this section. Average rate of change. If the graph of a function is not a straight line, the average rate of change between any 2 points is the slope of the line containing the 2 points. The line containing the points is called a secant line. Okay. So we got an official definition here. Let x1 f of x1 and x2 f of x2 be distinct points on the graph of a function f. The average rate of change from x1 to x2 is given by f of x1 f of x2 minus f of x1 over x2 minus x1, and I gave a little picture, and we'll zoom in a little bit so we can see the picture a little bit. Zoom in. There we go. So there's my little picture. And so the first part is just saying that the average rate of change is just the slope of the line between them. That's called a secant line. And then they give a fancy little formula, but it's just slope. Remember, f of x2 just means my y-coordinate, so y2. F of x1, that's just another name for my y-coordinate, y1. Remember I said kind of one at the beginning of the lectures that that f of x thing bothered me when I was in 8th grade until I figured out that you could just replace the f of x's with y's. So f of x2, replace it with y2. F of x1, replace it with y1, and so we just have the formula for slope. And I only have 30 seconds, so I'm going to have to do a video that's about a minute long just to do this last problem, but that's life. We need to end this video.